So we're gonna take a look now at this is I created some arbitrary rules for strings of beads and their colors, and so different colors in certain positions within bead groups, and certain combinations or sequences meant different bead costs. And then you limit the number of beads available, and you also limit the total cost that the maximum cost, and then it'll solve and try to find a solution for the size of the bead groups and how many beads are used and what colors they are and what orders they're in. And I did one implementation using constraint handling rules, and I did another implementation using constraint logic programming. I won't go too much into that, but yes. Here I have, I was learning about threading, and I created a program that it has 3 threads, and they're managed by one main thread, or it's not the main threads, but it's that's what I called it, one manager thread. And the first thread is a timer, and it ticks at regular intervals that kind of increase and decrease over time, just because I thought that'd be fun if it changed over time. um, and the second thread, well, let's talk about the third thread. So the third thread, at these intervals, or these elapsed points. So like after 3 seconds have elapsed, after 4.25 seconds have elapsed, blah 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 blah, it will um, send a signal to the other 2 threads saying, "Hey, associate E with 5," or "Hey, associate F with 6," or "Hey, associate G with 7." And so the blocker thread will be like, "Okay, recording that fact locally in my thread." But um, when the when it's in one of these blocked intervals, so here we're blocked for 5 seconds, the timer will not receive the updates until after it becomes unblocked again. And oddly enough, for this, when I was doing my practice run of this presentation, I realized that I had disabled the blocking for kicks, and I forgot to re-enable it. So the example is not really showing the actual functionality, but it does. It normally works. And then after 52 seconds, it'll kill everything if it's still running for whatever reason, just kind of as a failsafe. And you can see that I use color coding to try to figure out what's going on as I was writing this, because I was just learning about how to create threads and how to send signals and block signals and all this other stuff. And I was also learning about thread, lo thread local predicates and things like that. So I was learning a lot, and this was really helpful. It's a very helpful exercise in learning that. Here I did. I was trying to figure out. I was trying to do an animation, and I wanted to use the timer class, but I needed to know what would happen if the drawing of the frame that was triggered by each timer tick, if that drawing if it took longer than the tick interval, what would happen? I wanted to know if like it would maybe interrupt itself and try drawing the next frame while the previous frame was still being drawn. So I did some experiments, and here's the first method that I tried, which was not using a listener thread. Um, and as you can see, I used a message queue, so that way if the queue is still full, meaning that the previous tick had not yet been completed, then it would not be able to trigger another tick thing. So here, this is with the listener thread, um, but everything else is still happening in one thread. So for 5 seconds, tick every 2 seconds, and for every and on every tick, we're going to sleep for 1 second. Cool. We only completed 1 sleep pair because there was only time for 1 sleep pair. Okay, but what if the okay, so for 5 seconds, tick every 2 seconds, and on every tick, we're going to sleep for 5 seconds, which is obviously longer than 2 seconds, so let's see what happens. Okay, no more ticking. And we only did one sleep pair. Okay, as expected. And these numbers here, so like this, the ones that are in brackets and stuff like that, those correspond to the tick number that triggered all of that. So, yes. So now we're sleeping in a different thread. But we're still ticking, the timer is still running in the same thread as everything else. But the sleeping will be happening in another thread. Oh, and you see that we have, so the sleeps, we did more sleeps this time because the sleeping was happening in its own thread. Okay, for 5 seconds, tick every 0.5 seconds, and on every tick, we're going to sleep for 6 seconds, and again, we're sleeping in another thread. Whoa, tick, 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 tick. And so you can see the queue is not full because we finished sleeping, we return from triggering sleeps immediately because the sleeping is happening in another thread. And you can see that everything is overlapping. So this is the end of the first sleep that was triggered by the first tick, and then so we were able to complete 9 of them because for each of the 9 ticks. And this is not a correct description of what's going on. Now we're ticking in another thread and sleeping in another thread. So that's why it's on. So, yes. Not that much different from the previous. Which led me to suspect that perhaps the whole timer thing was going on in another thread to begin with. And that is the end of my presentation. If you liked it and you want to see more from me, you could take a look at, I'll probably also share a link to these other videos. Here's my Micro 1 project where I wrote a Flappy Bird-like video game on a 2-line LCD with a microcontroller and capacitive touch. And here is a kind of a real-time demonstration of a real-time audio-visual demonstration of some DSP concepts and speech synthesis stuff. So combining some of the stuff I learned with in my linguistics classes, phonetics and phonology, with some of the things that I learned when I took an electronic music studio class. So yeah, it talks about filtering and other stuff. So I wrote this program. I forgot to mention that. I wrote it in Max MSP. And yeah, so that's also something you might be interested in looking at if you like my content. So yes, have a great day and thanks for listening.